Hi everyone, today I will explain to you chapter 5 and 6 of BT12103 Financial Management under the topic of the time value of money. Okay, at the end of the chapter, the student should be able to construct cash flow timeline to organize your analysis of problem involving the time value of money, and you also must be understanding the many types of concept of time value of money. The timeline actually identifies the timing and amount of a stream of payment, both cash received and cash spent, together with the interest rate earned. So actually the timeline are very critical. It will be the first step for you to analyze or solve financial problem with regards to money. Okay, so basically the timeline will be typically expressed in years, but it could also be expressed as month, days, or any other time. So you have to look at the magnitude of time with regards to any problems or issue when you want to settle the time value of money problems. Um, Okay, this is an example of how the time value of money problems translated into a timeline. Okay, so timeline is quite is the most crucial process where when you are dealing with any issues of time value, try to understand the issues and try to translate it into timeline. Okay, let's now do some example of how to construct the timelines. Okay, so look at this problem. So the 4 years timeline illustrates the following. Normally in the case of time value of money, there will be an information, at least three informations for you be able to construct the timeline. One is the amount. This is the amount. Either is a is a cash inflow. Cash inflow is a positive amount, or cash outflow. Cash outflow is a negative amount. There must be also one is amount, either it's a positive or negative, either it is in a present value or future value. Okay, number two, there must be an information of the interest, and number three, the time. Okay, so here in this case time is 4 years, 0 1 2 3 4. Okay, okay, in the timeline, your timeline will always start from zero. Okay, so look at this. Your timeline should always start from zero. Okay, so the 4-year timeline illustrates the following. The interest rate is 10%. Here is 10%. The cash outflow of 100 occurs at the beginning of the first year. When it say beginning of the first year, it will be at the end of year 0. So it should be here, negative. Okay, so followed by cash inflow of 30. This is a positive amount because it is inflow, and 20, this is also a positive amount in year 1 and year 2, and a cash outflow. Again, this is a cash outflow, so there will be a negative amount of $10 in year 3, and a cash inflow, that's another positive amount of 50. So basically your timeline is a straight line that will start with 0, okay, and will end at sometime in later, okay, and this time, okay, could be years, could be in years, month, week, and so on and so forth. Uh, uh, um, um, Depending on the question or the problem that you are facing. Okay, so basically timeline example, it start by zero, it start with zero, should having amount, interest, time, or should be at least having two information, either is interest or time, or amount or interest, because in the problem of time value money, you normally settle the variables, one of the variable that is missing, either it's amount or interest or time. Okay, let's now look at the many cases or many concept or type of time value of money. Okay, we start with the basic one. So the basic one is a future value or a simple future value. Okay, number two is a present value, a simple present value. A simple future value and a simple present value means that there will only be one inflow or outflow of money. If I may draw the timeline for this, it means that I start with zero. Let's just take an example, time value of 5 years, 3, 4, 5 years. So a future value means that we will be interested to know what is the amount here, at the future here. What is the value sometimes in the future, in this case at the end of 5 years, right? If present value, if we want to know what is the amount that is required here in the present value to achieve certain value in the future. For example, contoh, future value of what is the future value of 100k here, 100k if you put here, at the end of 5 years, 5 years here, if it is will enjoy 5% interest rate. Okay, so we would like to know what is the future value of 100k. Okay, 5 years ahead, if there will be interest of 5%. If present value cash, opposite of it, what is the amount, for example, what is the amount required at the present value here if I want to achieve 100k here? So what is amount required here at the year zero? Okay, if that money can be saved at the saving account that we give 5%. So what is it? So the amount should be less than 100k lah. And that is a case of simple future value and a simple present value. Okay. Another type of time value of money is annuity. Annuity. There be 4 types of annuity. Okay, one is the future value annuity that can also be categorized as an ordinary annuity or annuity due. I will explain it later. There will be a slide to explain more about this, but at least you have the mind mapping at this stage of the many type of time value of money. Number 2 is a present value annuity. It could also an ordinary present value annuity or annuity due. Okay. So the difference between simple future value and simple present value with annuity is that annuity will involve a series of payment. In the case of simple future value and present value, there will be only one lump sum amount, but annuity will involve a series of payment. series of payment. So take an example like this. We have 1, 2, 3, 4. Okay, 5 lah. So a future value annuity is a case where what happen if, say, you put a 5k amount here at year 1, another 5k at year 2, 5k at year 3, 5k at year 4, and 5k at year 5. So what is the amount, for instance, what is the amount here? What is the amount, the future value amount from the series of 5k deposit each year? So this case is an annuity. It's an annuity because it involves a series of same amount. If it is here 5k, 5k, here 4k, 4k, and 4k, so basically this involve two series of annuity. The first one is 5k, another series of 4k. The idea behind annuity, two things. It must be a series of payment, one. Number two, the payment must be the same amount. Same amount. Okay. Okay. So if it is future value annuity, we want to know what is the future amount here at the end of the time series. Present value annuity, opposite of it, it is about how much amount of money here. This is a present value annuity. Here is a future value annuity. Okay, what is the amount here? Okay, that is required. Okay, for the time series to be able to disburse the amount of, say, 5k each year for 5 years. So at the end of the 5 years, the amount will become a zero. So it will be a series of lump sum money here that will disburse a series of payment in annuity at the interval time or year, okay, until at the end of the timeline, the amount become zero. Here we start with zero, okay, and the payment will be a series of payment in the future. So what is the amount in the future value? But the opposite of it, present value, we start with certain X amount here that will be disbursed 5k each year until year 5. At the end of timeline, the amount will be zero. Okay, so that is the another type of time value, and the last one will be the perpetuity. Okay, the perpetuity is the case of where the amount disbursed, or the amount, or the dividend, or the interest will be earned forever. Yeah, forever. So means that if I have an X amount here with an interest, 5% interest, example, so this amount of money, what is the amount of money here that will give me Y dividend or return, okay, that will goes forever. So it's a perpetuity, so it will be a forever. So it will be in forever. Okay, all right. So the time value of money is actually the first principle of finance. It is crucial for the student of finance to be able to understand the time value of money, because later on, depending on the subject matters that you are dealing with, the time value of money will be used in the context of firm and personal finance. In the context of firm, normally it will be used for a project assessment. There will be a chapter, I think chapter 11 or 12, where you guys will be covering another utilization of time value of money in the case of project assessment. So time value of money will help the management or the analyst to identify if the project is profitable to be implemented, to be invested. On the personal basis, on the personal finance concept, normally time value of money is the pinnacle, is the the crucial part where the information will be used for education, planning, or retirement planning. So basically, as I mentioned, the time value of money is the most crucial elements or principle with regards to finance. Okay, for calculation or settlement of time value of money problems, there are many ways that you'll be able to use, either by using mathematical formula or using Excel or any spreadsheets. You may use also the time value of money table, as well as the most, I think the most easiest one is by using the financial calculators. Okay, but in this subject, it is important for you to be able to remember the mathematical equation for the each of the time value cases. Okay, we start with the first time value of money case. Is a simple future value. As I mentioned to you, this is case where you want to settle the amount in the future, future value. Okay, so your timeline must always start with 0. Okay, 1, 2, 3, 4. So what is the amount in the future? If say we start with an amount of any amount here in the present, because you want to calculate the future value. So the formula, mathematical formula of future value is present value multiplied by 1 plus interest rate. In this case, for example, the interest rate is 10%. I will be 4. So future value is PV, present value, multiplied by 1 plus I to the power of n. So if you translate here, so future value here will be PV. Say for example here you have 100k. Okay, so it will be 100,000 here. 1 plus 10%, so 1.1. What is the n? 4. Okay, then you settle. Okay, so the formula for future value, simple future value is FV equal to PV multiplied by 1 plus I, interest to the power of n. Okay. So in the case of present value, the key question will be what is the value today of cash flow to be received in the future. Okay, so if we translate it into timeline, 0, 1, 2, 3, 4, 5. In the case of present value, what is the amount here? This is present. Okay, for a cash flow to be received in the future. Say you want to achieve 100k in 5 years, where you save in a saving that will give you 7%. Okay, so what is the present value? What is the amount here that will be required to be deposited that will give you 100k in 5 years if it is deposited in a product that will give 7%. Okay, so future value, present value. The formula for future value is present value 1 plus I n. So you just, so you just, so present value will be FV divided by 1 plus I power of n. So here is, we want to achieve future value of 100,000. So 1.07 to the power of 5. So you can calculate it using calculator. So this slide is displaying the same formula for present value. Present value, the same thing as the previous chapter. So now let's discuss about the annuity. As I mentioned at the previous slide, there are 4 cases of annuities. One is that annuities, it could be present value annuity or future value annuity, and it could be an ordinary annuity, ordinary annuity, and could be an annuity due, same as this one, ordinary annuity or annuity due. Okay. So basically the annuity is a series of equal payment that are made at the end of equidistant point in time, such as monthly, quarterly, or annually, over a finite period of time. For example, 3 years, 5 years, or so on and so forth. If payments are made at the end of each period, the annuity is referred to ordinary annuity. Okay, let me explain. Okay, so this is annuity if it is involve a series of equal payment. Example, we start here 5K. Okay, start by 0, 1, 2, 3, 4, 5, 6. Okay, another 5K, 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 and we want to know what happened here. Okay, so this is number one. This is an annuity because it's a series of payment. Okay, and this is an ordinary annuity. Okay, because payments are made at the end of each period. Means that at period 0, okay, the payment will be made at the end of period 0 or at the beginning of year 1. So this is ordinary. So the difference between ordinary and annuity due is that, okay, if the 5K start immediately, in the case of, there will be 5K starting here, start at immediately. If it is immediately, then it is an annuity due. Okay, so this is annuity due because it starts immediately. So means that there will be one additional payment as compared to ordinary annuity, because the annuity due, in the case of annuity due, the payment start immediately. So it will not wait for the end of 0 or the end of year 0, but it will be starting at the start of year 0. Okay. So this is the formula, mathematical formula for the case of future value of an ordinary annuity. If you look at this formula, there be a payment here. So payment is the annuity payment deposited. In the case of, say, this is the timeline, okay. In the case of annuity, ordinary annuity of 3,000, okay. So this 3,000 is the payment. Okay. So for I and N, it is similar in the case of the simple present value and future value. Okay, look at the example of ordinary annuity. So how much money we will accumulate by the end of year 5 if you deposit 5,000 each year? How do you know this is annuity? Because of this each year. So means that time value 1, 2, 3, 4, 5, 1, 0, 1, 2, 3, 4, 5. You know that this amount will be deposited each year. Okay. For the next 10 years, or here, this is stack lah, that 5 years, end of year 5. Okay. In a saving account that earns 6%. Okay, so this will be an ordinary annuity because it will start at the end of year 0. If the question sound like this, how much money will accumulate by the end of year 5 if you deposit each year, or if you deposit 5,000 immediately? Immediately, contohlah, immediately. Now, each year for the next 10 years. So this is, if this is the words or the nature of the payment, so it will become annuity due. Right. So if it is series of annuity, then you can settle these problems by using the formula as I mentioned before. So the future value of annuity in this case is payment 1 plus IN minus 1 divided by I. So the formula will be 5,000 here, 1.06, 5 years, because we want to know what happened after 5 years, minus 1 divided by 0.06. Then you calculate using calculator. Okay, in the case of the present value of ordinary annuity, we will require, or we will measure the value today of a stream of cash flow occurring in the future. Okay, so this is the formula to settle the mathematical formula to settle the case of present value of ordinary annuity. Now let's look at the example of the case of present value ordinary annuity. So how much, this is an example, how much money you must save now, now, present value, okay, in a saving account that will give interest of 6% annually to receive 500 every year for the next 5 years. Means that what is the amount of money here that will disburse 500 each year for 5 years. So means that after year 0, after year 5, this amount of money will become 0 lah. So it will be fully disbursed. So in this case, using that, a formula. What is the formula for present value? Present value annuity. So you can use payment 1 minus 1 plus I and divide by I. So means that you can receive 500. 1 plus, what is the interest? 1.06. 5 divided by 0.06. You should be getting this amount. So this is a discounted cash. You only need 2,100 to actually giving you a stream of income that is totaling 2,500. 500 multiplied by 5, 2,500. You only need 2,106, 18 cents deposited in a saving account that will give you 6% to be able to withdraw 500 each year until year 5. So that is an illustration of present value ordinary annuity. Okay, the two previous example of annuity is illustrating the case of ordinary annuity. While I explained it already previously that annuity due is an annuity which all the cash flow occur at the beginning of each period, the beginning. For example, rent payment, okay, this example. So means that annuity due is where the payment will taking place at the beginning of the time, the period. So means that we don't need to wait for another 1 year. It will be starting here, here. So means that there will be a deposit each year at the beginning of the. So if you compare annuity due and ordinary annuity, is that the annuity due will start earlier by one time interval, plus 1 here, because if this ordinary, we will start here, but in the case of annuity due, it will start immediately here. So there will be an extra of one payment. So the consequences is that if you look at the next slide, is that there will be an additional multiply of one period of interest rate to the existing original formula of present value and a future value or annuity. So this is a formula, mathematical formula for future value of annuity due. So original formula for future value ordinary annuity will be until here. So as I mentioned, when there's an extra of 1 period, extra because the payment will start earlier at the beginning of the year, so there will be an extra 1 interest rate. So you just multiply by 1 plus I. It's the same concept that is used in the formula of present value annuity, as shown at the next slide. Okay, for the last case of time value of money, there are perpetuity. So perpetuity is annuity that continues forever. This is the idea behind it, and has no maturity. For example, a dividend stream on a share of preferred stock Okay, there are two types of perpetuity. One is level perpetuity and a growing perpetuity. So basically, this is a formula of level perpetuity. So example of case is that, for instance, say you want to find a value of what is the amount that you need to deposit in a, say a saving account, or for example an ASB account that we give 6%. Okay, so what is the amount that you want to deposit? Okay, if you want to get, say, 100K each year, so you just must, plug in the number using this formula. So PV is equal to the dividend, the payment, divide by 0.06. So what is the amount of, let me just calculate. Okay, 100,000 divided by 0.06. So you need 1.67 million. So means that if you have a deposit of 1.67 million, you put it in an asset or in an investment vehicle that we give 6%. So without doing nothing, that investment will give you 100,000 each year forever. So year 1, 100,000, year 2, 100,000, year 3, and so on and so forth. They'll be giving 100,000 each time frame. Okay, so that is the idea of perpetuity. So basically, I already covered all the types of time values. So it is important for you, as the objective, as mentioned in the objective of this chapter, it is important for you to be able to translate the problems of time value of money into a timeline, and by using that timeline, you'll be able to know and to understand what case of, or what type of time value problem that you are having, and in that method you'll be able to use the correct formula to settle the issues or the problem of time value of money. Thank you.